If you are looking to dive into the IT industry and learn networking, then the primary and foremost skill you need to acquire is IP address configuration and subnetting along with network topologies. No doubt, IP addressing and subnetting are a fundamental part of the IT networking field. These core concepts make the foundation of networking essentials, a must-have skill that you cannot bypass. So welcome to this course on IP addressing and subnetting from scratch. My name is Myra and I'll be your instructor for this course. My team ClayDesk and I are super excited to bring you this course to be able to walk you through complete IP addressing and subnetting configuration with step-by-step hands-on approach. Let me walk you through the course agenda. In this in-depth course, you will learn fundamentals of IP address and subnet masks, understand IP address classes and why we use them, create network and host ID, gain solid understanding of default gateway, see how MAC address works, how DHCP works. You will also learn the basic concepts of network topologies. You will work with variable length subnet masks and be able to successfully create subnets according to a host and according to a network. I have designed this course for anyone who is keen to learn IP addressing and subnetting. Anyone who wishes to gain solid understanding of what is IP addressing and how we can do subnetting, or anyone who is in the IT industry and wants to enhance knowledge, skills, and abilities. So why should you take this course? Well, like I mentioned earlier, these core concepts make the very foundation of IT networking industry. No matter where you go, which platform you work with, whether it is AWS, Azure, Google Cloud, Red Hat OpenShift, Oracle, IBM, or any other, being able to successfully configure IP addresses and subnet masks is a key. So you need to master these skills. I've also designed this course to be hands-on and interactive to make it easier to provide several quizzes, labs, and assignments. I value your feedback, so leave a review if you find the course valuable, and I regularly update my courses. So ask as many questions as you like. So what are you waiting for? Enroll in this course of IP addressing and subnetting from scratch, and I will see you guys in class. Hey guys, and welcome to this lesson on the important terms of IP and subnetting. So we're going to learn some fundamental terms of IP and subnetting which will be needed throughout the course. So we should have a good understanding of what they mean. So first, let's see what a bit and what a byte is. So a bit is the smallest unit of data in a computer. A bit has a single binary value and is represented by either a 0 or a 1. So for example, in computer languages, whenever you see a 0 or a 1, you know that it is a bit. So what is a byte? A byte is a term used to represent 8 bits of data. We just learned that bit is the smallest unit of data in a computer. So a byte represents 8 bits of data. One byte can hold about one letter, one number, or one special character. So let's move on to subnet mask. So what is a subnet mask? A subnet mask is a number that defines a range of IP addresses available within a network. A single subnet mask limits the number of valid IPs for a specific network. Each section of the subnet mask can contain a number from 0 to 255. So the minimum value is 0 and the maximum value is 255. We cannot go beyond 255 in writing a subnet mask. Next, let's see what an octet is. So the 32-bit IP address is grouped 8 bits at a time. Each group of 8 bits, which is 1 byte, is an octet. So each of the 4 octets are separated by a dot and represented in decimal format, which is known as dotted decimal notation. So the IP address consists of 4 octets. Moreover, let's move on to what a host and what a network is. So a host is a computer or other device that other devices can connect to for access to resources,
which can be like files, or services, which can be like any website, emails, or any database. And whereas a network is a collection of computers, cables, routers, switches, and other devices that are connected together to access and share resources. So a host is a single computer or device. However, a network is a collection of computers or cables, routers, switches, and even any other device. So in a network, computers share information and resources together. However, a host only connects to another host, another device, another single device to access any kind of information or resources. So this was the end of our lesson on the important terms that are needed in IP and subnetting. I hope you guys got a good understanding, and now I'll see you guys in my next lesson. Hey guys, and welcome to this lesson. So we're going to see how you can convert a decimal number to a binary number. So I'm going to demonstrate you step by step in depth so you guys can have a solid understanding how to convert any decimal number to a binary version of it. So let's look at the first main thing that you need to remember when you're converting any decimal number to a binary number. So the first and probably the most important step is to put down this row of values. As you can see, there are 8 numbers and you have to remember these 8 numbers. So in order to remember these values, start with the number 1, go from right to left and double that number 7 times. For example, start with 1 on the right side. So for your next number, double the 1. So 1 into 2 is equals to 2. So 2 is your next number, remembering to go from right to left. For your third number, double the 2. So 2 times 2 is equals to 4. To continue the sequence, double the 4. So 4 times 2 is equals to 8. Repeat this process until you double your original number 7 times. So let's take a look at the concept now. So the key to remember this conversion is that every single one of the values we put in that row are going to have either number 1 or number 0 assigned to it. To convert the IP address, we will take that string of numbers and start from left to right this time. So while writing the number row values, you're going to start from right to left, but during the conversion, you're going to start from left to right. For each value, we can ask this question: can I subtract this value from the decimal remaining? If the answer is no, then you put a 0 under the binary value, and if the answer is yes, then you put 1 there. So now we're going to do a step-by-step example. So we will take the IP address 154.31.16.13 and start with the first part, which is 154. So we will take each octet and separately convert its decimal number to a binary form. So the first step is that you ask a question: can I subtract 128 from 154? So the rule of doing is that you just take your number, which is 154, and keep on asking questions like this, that can you subtract that number from the row of the values one by one. So first we ask that can I subtract 128 from 154? So the answer is yes. So we assign 1 to 128. As you can see, we have written 1 under 128. For step 2, we will see and ask that can I subtract 64 from 26? The answer is no. So we assign 0 to 64. The third step would be that we will ask the question again, can I subtract 32 from 26? The answer would be no. So we assign a 0 to 32. For question 4, we will say, can I subtract 16 from 26? The answer is yes. So we assign 1 to 16. That will give us a remainder of 10, as 26 minus 16 is equals to 10. So next you should ask, can I subtract 8 from 10? The answer is yes. So we assign 1 to 8. Further, for step 6, we will have a remainder of 2, as 10 minus 8 is equal to 2. So you're going to ask the question, can I subtract 4 from 2? Answer is no. So we assign 0 to 4. Just remember this too, that you will always take the remainder of the values. So step 7 is, you'll ask the question, can I subtract 2 from 2? Answer is yes. So we assign 1 to 0. And we will have a remainder of 0 left. So the rest of the values in a row, we can assign 0. So now we know that a decimal number 154 is 100111010 converted to binary form. And to double check, we take the values assigned with 1 and add them together. So 128 plus 16 plus 8 plus 2 is equals to 154. So in our IP address, the next number of the second octet is 31. So let's do all those steps for 31 now. So you're going to first ask, can I subtract 128 from 31? The answer is no, so you will write 0. Step 2, can I subtract 64 from 31? The answer is no, so you will write 0. Step 3, can I subtract 32 from 31? The answer is no, so you will write 0. Step 4, can I subtract 16 from 31? The answer is yes, so you're going to write 1. So now you'll ask, can I subtract 8 from 15? Remember, it's the remainder. So the answer is yes, and you're going to write 1 under 8. Further, in step 6, you will ask, can I subtract 4 from 7? The answer is yes, so you're going to write 1. Step 7, can I subtract 2 from 3? The answer is yes, so you'll write 1. And step 8, which is the last step, you can ask, can I subtract 1 from 1? The answer is yes, so you will write 1 under 1. So the decimal number 31 is 0001111 converted to its binary form. And to double check, 16 plus 8 plus 4 plus 2 plus 1 is equal to 31. So our third octet number is 16. But this time we will perform the conversion in one step now. So you can see what we've done is the number is 16. We started from 128, remember, left to right. So can you subtract 128 from 16? No. Can you subtract 64 from 16? No. Can you subtract 32 from 16? No. Can you subtract 16 from 16? The answer is yes. So you will write 1 under 16. And we have no remainder left, so the rest values will be 0. So the decimal number of 16 is 0001000 converted to its binary form. And the last octet number is 13. So you're going to do the same steps again. Start from left to right, and you'll see that we only get 1s under 8, 4 and 1. So the decimal number 13 is 0001101 in its binary form. And to double check, you will again do 8 plus 4 plus 1, which is equals to 13. So now finally the IP address 154.31.16.13 has its binary form equivalent of 1001111.0001100.00000011101. So guys, this was the end of our lesson on the conversion of decimal to binary. And if you want to do the conversion of binary to decimal, you just do the vice versa of this. So I hope you guys got a good understanding of how we can do the conversion. Hope you guys could easily understand my example and were able to understand how you can actually convert a decimal number to its binary version. And now I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on conversion from a binary number to a decimal number. So the fundamental learning of this concept is that the first and probably most important step is to put down this row of values, which is 1, 2, 4, 8, 16, 32, 64 and 128. So in order to remember these values, start with the number 1, go from right to left and double that number 7 times. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, and 64 times 2 is 128. So this is an easy way to remember it. And the key to remember is to place the number row values under the binary numbers from right to left. So let's take a look at an example. We will take the binary number, for example, 100111011. So I have written it in bold over here, and under that we have written the number row values, as you can see, from right to left. So 1, 2, 4, 8, 16, 32, 64, 128 is exactly under the binary number. So the second step is that you put a line below the number of values and only put the number row of values under the binary number which has 1. So wherever there is 1, you will only write it again at the bottom. So as you can see, under the 0 values there is nothing, but under the 1 values I have written the same value of that from the number row value. And the next step you do is you add those number 1 values. So as you can see, I've just added a plus mark after 128.16 and after 8 to 1. So you're going to add them. So once we add them, you will get your answer 155. So 155 is the decimal version of this binary conversion. So this conversion is really easy to understand. All you need to do is write the number row values under your binary number. Only write the numbers under 1, add them, and you'll get the total value. And that will be your decimal number of that binary number. And now I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on what is IP. So we're going to learn in depth about what is IP, what are IP addresses, and their types. So let's look at the definition first. IP stands for Internet Protocol. The Internet Protocol is the method or protocol by which data is sent from one computer to another on the Internet. Each computer, which is known as the host, on the Internet has at least one IP address that uniquely identifies it from all other computers on the Internet. The Internet Protocol is the basic unit of data transfer. IP software performs the routing function. So each computer has its own unique IP address. So now let's see what is an IP address. An IP address is a unique global address for a network interface, which is a 32-bit long identifier. It encodes a network ID and a host ID. These are also known as network number or host number in an IP address. So the IP addresses allow the location of literally billions of digital devices that are connected to the Internet to be pinpointed and differentiated from other devices. Most commonly we study IPv4, which is IP version 4. So as we just learned that each Internet has a specific IP, so every device connected to the Internet has a specific unique IP address. So now let's see what IP version 4, IPv4 is. So an IP version 4 address consists of 4 numbers, each of which contains 1 to 3 digits with a single dot separating each number or set of digits. Each of the 4 numbers can range from 0 to 255. This versatile group of segmented numbers create the addresses that lets you and everyone around the globe to send and retrieve data over our Internet connections. Without this numerical protocol, sending and receiving data over the World Wide Web would be impossible. So IP version 4 IP addresses are needed to send any kind of information or receive any kind of information. Here now let's look at the parts of an IP address. This is an IP address 172.16.254.1. So here as you can see, the decimal numbers are converted to binary, and you can see that there are 8 bits in 1 byte. We just learned that in one of the previous lessons. So there are 8 bits, you can count them, and 8 bits is equals to 1 byte, and 1 byte is equals to 1 octet. So there are 4 octets divided by dots. So all the 4 bytes combined have 32 bits in total. So let's see what is IP version 6 now. We study IP version 4, but we also need to have a good understanding of IP version 6. So the IP version 4 that we learned about supports a maximum of approximately 4.3 billion unique IP addresses. All of these have been already used now. So that is why a new version was introduced, which was called the IP version 6. The IP version 6 supports, in theory, a maximum number that will never run out. So let's look at the format of an IP version 6. An IP version 6 address consists of 8 groups of 4 hexadecimal digits. If a group consists of 4 zeros, the notation can be shortened using a colon to replace the zeros. Here's an example of IP version 6 address. I know it is a little complicated when you look at it. That's why we only study IP version 4, which is only 4 octets and easy to understand. Now we're going to move on to the types of IP addresses. There are two types, private IP address and public IP address. So first let's see what is private IP address. So these are used inside a network. For example, a home network that is used by tablets, Wi-Fi cameras, wireless printers and desktop PCs. These type of IP addresses provide a way for devices to communicate with the router and the other devices on the private home network. Private IP addresses can be set manually or assigned automatically by the router. And public IP address on the other side are used on the outside of a network and are assigned by an ISP, which is an internet service provider. It is the main address that a home or business network uses to communicate with the rest of the network devices around the world. It provides a way for the devices in a home, for example, to reach an ISP and allowing the devices to access websites and communicate directly with other computers and servers around the world. So private IP is only used in home routers to communicate between servers in a local home. However, the public IP address is connected to your ISP, and whenever you want to access any website or want to send or receive any data from an external site, you will have to send the information to the ISP first, and from the ISP your information is transferred to the external site. So this was the end of our lesson. Hope you guys got a good understanding of what we learned, and now I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on classes of IP addresses. So there are 5 types of classes: class A, B, C, D and E. Each class has a range of valid IP addresses. The value of the first octet determines the class. IP addresses from the first 3 classes A, B and C can be used for host addresses. The other 2 classes are used for other purposes. Class D for multicast and Class E for experimental purposes. So the system of IP address classes was developed for the purpose of Internet IP addresses assignment. The classes created were based on the network size. For example, for the small number of networks with a very large number of hosts, the class A was created, and the class C was created for numerous networks with small number of hosts. So let's look at class A first. So the first bit of the first octet is always set to 0 in class A, so that the first octet ranges from 1 to 127. So the minimum number of class A can be 1 and the maximum number can be 127. The class A address only includes IP addresses starting from 1.x.x.x to 126.x.x.x. So this is the range that we need to remember about class A, so that whenever you see an IP address and want to identify which class it belongs to, and if there is any number from 1 or 126 in the first octet, you're going to know that you have to write about class A, and it is the IP address of class A. The IP range 127.x.x.x is reserved for loopback addresses. The default subnet mask for class A IP address is 255.0.0.0. So we just mentioned loopback address. A loopback address is a type of IP address that is used to test the communication or transportation medium on a local network card and/or for testing network applications. Data packets sent on a loopback address are rerouted back to the originating node without any alteration or modification. You can also check your loopback address from the CMD command in your Windows. So I will also have a lab lesson of the basic network commands in which I will also show you guys how to check your loopback address. Now let's move on to class B. So in the class B type of IP address, the first 2 bits in the first 2 octets are set to 0. Class B IP addresses range from 128.0.x.x to 191.255.x.x. So this is the range for class B, 128 till 129. So you need to remember this too. So the default network mask for class B is 255.255.x.x. Now let's look at class C. So the first octet of this class has its first 3 bits set to 110. Class C IP addresses range from 192.0.0.x to 223.255.255.x. So the range of Class C you need to remember is that 192 till 223. The default subnet mask for Class C is 255.255.255.x. So now we're going to move on to Class D. So the first 4 bits of the first octet in Class D IP address are set to 1110. Class D has IP address range from 224.0.0.0 to 239.255.255.255. So the range for Class D you need to remember is 224 till 239. Class D is actually reserved for multicasting. In multicasting, data is not intended for a host but multiple ones. That is why there is no need to extract host addresses from the Class D IP addresses. The Class D does not have any subnet mask. And lastly, we have Class E. The Class E IP addresses are reserved for experimental purpose only, for example, for any kind of research, any development or any study. The IP addresses in the Class E ranges from 240.0.0.0 to 255.255.255.254. This Class 2 is not equipped with any subnet mask. So this was the end of our lesson on the different classes of IP addresses, and now I'm going to see you guys in my next lesson. Hey guys, and welcome to this lesson on the classes of IP, examples and identification. So this is kind of an activity lesson in which first I will give you guys some examples of IP addresses, and then after that I will give you a small quiz in which you guys will have to identify the IP addresses and tell me which class they belong to. So here are some examples of class A, B, C, D, E of IP addresses. So I've given 2 examples of each class here, as you can see. So let's look at class A first. We have 12.0.30.0 and another example is 100.11.15.20. So the rule is, this is the rule that you have to remember when identifying the classes of IP addresses. Whenever you're given an IP address, you're only going to look at the first octet of the IP address. Just remember to look at the first octet. So here, the first octet of the first example of class A IP address is 12. And after looking at 12, you're going to see that in what range it belongs to. So 12 belongs to the range of class A IP address. So you're going to know that this is a class A IP address. So here I've given you all the examples of class A, B, C, D and E. Just take a look at them, and that's why you need to know and remember the range of the IP addresses classes, so that whenever you see an IP address, you will be easily able to identify which class it belongs to. So now here is an identification quiz I've given you guys. I've written all of these IP addresses myself. They are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 IP addresses in total. So pause the video, take your time, and remember the rule to only look at the first octet when identifying the classes of IP addresses. So just take the first IP address, which is the 90.0.30.01. Look at the first octet, which is 90, and then remember which range 90 belongs to. And when you remember that, you're easily going to know that which class it belongs to. So these are the answers of these IP addresses classes. I've written all the answers in front of them, so you can see the first one belongs to class A, the second one belongs to B, then A, D, A, and then D, D, C, A, C. So I hope you guys could also identify some of the IP addresses of which classes they belong to. It's really easy. All you need to do is again look at the first octet, remember the range of each class, and then you'll easily identify which class it belongs to. So this was the end of our small activity kind of lesson. Hope you guys got a good understanding, and now you will be able to identify any classes of IP addresses, and I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on default gateway. So let's look at the concept of default gateway first. A default gateway makes it possible for devices in one network to communicate with devices in another network. If a computer, for example, requests a web page, the request goes through the default gateway before exiting the local network to reach the internet. Think of a default gateway as an intermediate device between the local network and the internet. The default gateway transfers internal data to the internet and back again. The default gateway device passes traffic from the local subnet to devices on the other subnets. And do note that in most homes and small offices, the default gateway is a router that directs traffic from the local network to the cable or DSL modem, which sends it to the internet service provider. So now let's see how traffic moves through a default gateway. All the clients on a network point to a default gateway that routes their traffic. The default gateway device passes this traffic from the local subnet to other devices on other subnets. The default gateway connects a local network to the internet, although internal gateways for communication within a local network are used in corporate networks. The default gateway in a home network, for example, understands specific routes that must be taken to move internet requests from a computer out of the network and onto the next piece of equipment that can understand what needs to be done. From there, the same process happens until the data reaches its destination. With each network that the traffic hits, that network's default gateway relays the information to the internet and back to the computer which requested it. This process is understood based on the IP address that the originating device requests. Moreover, now let's move on to the types of default gateways. So there are actually two types of default gateways. One of them is that in home or small business networks with a broadband router to share the internet connection, the home router serves as the default gateway. And another type is that in home or small business networks without a router, such as for residences with dial-up internet access, a router at the internet service provider location serves as the default gateway. So there are two types. One of them is that if you have a router in your home or small business network. The other one is that when you don't have a router. So when you don't have a router, your ISP, your internet service provider, they have a server in their location which acts as your default gateway. Next, we're going to see how you can find your default gateway IP address. You need to know the IP address of the default gateway if there's a network problem or you need to make changes to your router. In Microsoft Windows, the IP address of a computer's default gateway can be accessed through command prompt, CMD for short, with the ipconfig command as well as through the control panel. I will also show you guys how to check your default gateway IP address in the lab lesson of my basic network commands. The netstat and IP route commands are used on Mac OS and Linux for finding the default gateway address. So this was the end of our lesson on default gateway. I hope you guys got a good understanding of what default gateway is, how it works, and what are its two types. And now I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on MAC address. So we're going to talk in depth about MAC address and how we can find it, what's it about, and what's its use. So let's take a look at the concept first and the meaning behind MAC address. So MAC address, MAC stands for Media Access Control. MAC addresses are unique 48 bits hardware number of a computer which is embedded into a network card, which is also known as network interface card during the time of manufacturing. MAC address is also known as physical address of a network device. So each computer when it is made has a network interface card, and each network interface card has a unique MAC address. So this is a physical address of a computer. Now let's take a look at the format of MAC address. MAC address is a 12-digit hexadecimal number, 6-byte binary number, which is mostly represented by colon hexadecimal notation. The first 6 digits, for example 00:40:96, of a MAC address identify the manufacturer, called as OUI, which is Organizational Unique Identifier. Here are some OUI of well-known manufacturers. So for Cisco, the OUI is CC:46:D6. For Google Inc., the OUI is CC:5A:B4. For Hewlett Packard, the OUI is 3C:D9:2B. And for Huawei Technologies Co. Limited, the OUI is 00:9A:CD. So the rightmost 6 digits represent network interface controller, which is assigned by a manufacturer. So the first 6 digits are of the OUI, which is from the manufacturer, the company, they are the same. But the right 6 digits represent network interface controller, which are different, but they are assigned by the manufacturer too. So here is a picture of a network interface card. As you can see, this is the network interface card and it is plugged into your computer, inside your computer. So this is the MAC address on it. So you can see 885B32344 is the MAC address of this network interface card. Moreover, let's see the types of MAC address. So there are 3 types: unicast address, multicast address, and broadcast address. So in unicast address, the frame is only sent out to the interface leading to a specific NIC. So in unicast, you only send it to a specific unique NIC. For multicast address, you allow the source to send a frame to a group of devices. So you can send frames to a group of devices, not a single device like unicast. And in broadcast address, you send the frame to all the devices in the local area network, which is the LAN. So unicast is for a single device, multicast is for a group of devices, and broadcast is for all the devices in your LAN. Now let's see how to find your MAC address. The command for Unix/Linux is ipconfig-a, then you go to IP link list and then IP address show. The command for Windows OS is ipconfig/all. So I'm also going to show you guys how to find your MAC address in Windows OS using the command prompt in my basic network command lab lesson. And for Mac OS, you write TCP/IP control panel. So this was the end of our lesson on MAC address. I hope you guys got a good understanding of what MAC address is and what it is used for. So now I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on basic network commands. So this is actually a lab lesson in which I will show you guys hands-on how you can search your network commands. I will only show you guys how you can check out the basic network commands. So you go to your search tab, and when your search tab opens, you're going to search over there CMD. This is a short for your command prompt. Here you can command anything to your computer and it will show you guys the answer to that command. So once your command prompt open, it looks like this. I'm going to make the size of it a little bigger so you guys can also clearly look at it. Here you can see what it shows us. It just writes C/user/Myra, which is my name and my computer's name, so it will give me that. So after that, I'm going to show you guys the first one, which is ipconfig. So you're just going to type ipconfig and it will give you guys your Windows IP configuration. So here you can see your connection specific DNS suffix, which is your home. Then you can see your link local IP version 6 address. You can see the IP version 6 address as an example. We've already studied that. Then it also shows you your IP version 4 address, which is 192.168.19.3. So we've also studied IP version 4 address. So it's really easy and you can check this out. Now it also shows us its subnet mask, which is 255.255.255.0, which is a class C subnet mask. And lastly, it also shows us its default gateway, which is 192.168.10.1. So you can see you can get all your IP addresses from this ipconfig command prompt. Next, I will show you guys how you can do the ping command. So you're just going to write ping and press enter, and here it will give you all of the list of these things. So you can use ping to test both the computer name and the IP address of the computer. So as this is only a basic network commands lab lesson, we're not going to go in depth in detail about what all of this means. So I'm just going to tell you how you can just use the ping command prompt. So next I'm going to show you the basic network command tracer-t, which is also known as tracer route. So you're only going to type TRACERT and then press enter. So as it shows us, a target name or address must be specified. So what you do after that is that you type a specific host name. So you can write, for example, www.google.co.in, and you can trace the path of it. And so next I will show you guys the ARP command prompt. The ARP displays and modifies entries in the address resolution protocol, ARP stands for that, which contains one or more tables that are used to store IP addresses and the resolved Ethernet or token ring physical addresses. There is a separate table for each Ethernet installed on your computer. So you're only going to type in ARP and then press enter. And after that, you'll get the interface table. It will give you your IP address at the start, and then it will give you your internet addresses in a table with your physical addresses and their types, if they are dynamic or static. And lastly, I will show you guys how to find your loopback address. It's not actually you find your loopback address. The loopback address is the same which we learned in our lessons, that it is 127.0.0.0. So what we write is ping and then loopback. So it gives us if it's working or not. So it says pinging Myra with 32 types of data. So what it shows us is the ping statistics. It shows us that the packets sent were 4, the received were 4, and lost were 0. So there is 0% loss. So what it tells us is that the loopback address works. 4 packets were sent and the 4 packets were received. So there was no loss. So this was the end of our lab lesson on basic network commands. Hope you guys got a good understanding how you can use the command prompt to search these basic commands. You can also search on Google for more lists of basic network commands you can use and find out. So now I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on network and host ID. So in this lesson we're going to look at what is network and host ID and why we use them and how are they used in IP addresses. So let's look at the definitions first. We've also done these definitions in our first lesson. So we're going to see what is a host and what is a network. So a host is a computer or other device that other devices can connect to for access to resources, which can be any files or services, which can be like a website, an email, or any kind of database. Whereas a network is a collection of computers, cables, routers, switches, and other devices that are connected together to access and share resources. So a host, for example, is like a single device, and a network is a group of devices. Now let's take a look at the basic concepts of what a network ID is and what a host ID is. So the network ID, it tells us which network the device is part of, while the host ID, it identifies that unique device within the network. So think of the network ID as the suburb you live in, and the node, which is also called the host ID, as your street in that suburb. You can exactly tell where someone is if you have their suburb and street name. In the same way, the network ID tells us to which network a particular computer belongs to, and the host ID identifies that computer from all the rest that reside in the same network. So let's take a look at this picture to understand our concepts. So you can see a small network. We have assigned a class C IP range for this network. Remember that class C IP addresses are for small networks. So looking now at host A, you will see that its IP address is 192.168.0.2. So the network ID portion of this IP address is in blue color, which is 192.168.0, and the host ID of this IP address is 2. So now I suppose that the next question you would ask is, how do I figure out which portion of the IP address is the network ID and which is the host ID? So that's what we're going to look at in the next slide. So for each IP address class, we have a specific network and host ID. So the network class helps us determine how the 4-byte or 32-bit IP address is divided between network and host portions. So here, as you can see, we have class A, B, C, D, and E. The blue colored are in the network IDs and the yellow colored are the host IDs. So you can see, and you also have to remember this, that for class A, the first octet is the network ID and the rest 3 are the host ID. For class B, the first 2 octets are for network ID and the last 2 octets are for host ID. Whereas for class C, the first 3 are for network ID and the last single one is for host ID. And there are no host ID for class D and E because we use them for multicasting and for experimental purposes. Also notice that there are only few class A networks but many host IDs, whereas class C has a lot more networks and fewer host IDs. So this was the lesson on network and host ID. Hope you guys got a good understanding of what they mean and how they are implemented in an IP address, and how we can identify network and host ID in the classes of IP addresses. And now I'm going to see you guys in my next lesson. Hey guys, and welcome to this lesson on network and host ID examples. So we're going to look at some examples of network and host IDs with classes of IP addresses so we can have a solid understanding of how we can use them. So let's take a look at the class A example. So any class A network has a total of 7 bits for the network ID, bit 8 is always set to 0, and 24 bits for the host ID. So as you can see in this picture, we have an IP address of class A. So you can see that the blue one is for network ID and the yellow one is for host ID. Only 7 bits are for network ID and 24 bits are for host ID. So what now we do is that we need to find out that from these bits how many networks or how many hosts we can have. So it's really easy. So all you have to do is take the number of bits. So let's do for the network ID first. So we can see we have 7 available bits for network ID. And what we do is we just take the number and make it to the power of 2. So 2 raised to the power of 7 is equals to 128 networks. So we have 128 networks with class A IP address network ID. And just with the hosts, we have 24 available host bits. So what we do is 2 raised to the power of 24 and we get 16777,216 hosts. So the more the bits used, the greater the number. This is why class A networks can have so many hosts and therefore are large networks. So now let's take a look at class B. So class B networks have 14 bits for the network ID, bits 15, 16 are set and can't be changed, and 16 bits for the host ID. That means you can have up to 2 to the power of 14, which is equals to 16,384 networks, and 2 to the power of 16, which equals to 65,536 hosts in each network. Furthermore, let's take a class C example. So class C networks have 21 bits for the network ID. As you can see, there are 21 bits with colored blue, and bits 22, 23, 24 are set and can't be changed. And 8 bits for the host ID. That means you can have up to 2 to the power of 21, which is equals to 2097152 networks, and 2 to the power of 8, which is equals to 256 hosts in each networks. So easily, all you have to do is just take the number of bits and raise it to the power of 2, and you'll get how many networks and how many hosts you can get. Also, this is why class C networks have a large number of networks but with only 256 hosts per network. So this was a lesson on the examples of network and host ID, how you can see and calculate how many networks and hosts you can get from the bits of an IP address. And now I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on subnet mask. So let's see what a concept of subnet mask is. So a subnet mask is a 32-bit number that makes an IP address and divides the IP address into network address and host address. So a subnet mask is made by setting network bits to all ones and setting all host bits to all zeros. So within a given network, two host addresses are reserved for special purpose and cannot be assigned to hosts. The 0 address is assigned a network address and 255 is assigned to a broadcast address, and they cannot be assigned to hosts. So the two special reserved host addresses are the first one, which is 0, and the last one, which is 255. So here are how subnet masks are divided into IP classes. First, let's take a look at class A subnet mask. So we already know that for class A, the first part is for network and the last 3 are for the host. In class B, the first 2 are for network and the last 2 are for host. And for class C, the first 3 are for network and the last one is for host. So all you need to remember about subnet mask is that whenever you see a network ID, you're going to write 255 under it. And whenever you're going to see a host ID, you're going to write 0 under it. So it can be clearly seen over here. Under the network IDs, we have 255 and under the host ID, we have 0. It's really easy. The subnet mask is really easy to understand. All you have to do is 255 for network and 0 for host. That's it. So this was the end of our quick lesson on subnet masks and how they are divided into the IP addresses classes. Hope you guys got a good understanding of what they mean. And now I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on what is broadcast ID. So let's take a look at the concept first. So for example, you're a government of a small area and you want to send the same message to everyone living inside that area. So what you're going to do is use the broadcast system and send that message to everyone with that broadcast address. Same thing goes with the network. So what you do is that a simple message is sent to all the clients on a local area network relayed through a broadcast address. So a broadcast address is an address used to indicate that information being sent out should be delivered to every client on the local area network. These addresses are always the highest number possible in a network address or subnet. So how do you find a broadcast ID? The broadcast address for an IP version 4 host can be obtained by taking the complement of the subnet mask and then performing an operation with the host's IP address. Take the host's IP address and set to 1 any bit positions which hold a 0 in the subnet mask. So now let's see example of broadcast ID with IP classes. So what you're going to do is replace each host portion with the highest number you can create with 8 bits, which is 255. So let's take a network class A example, and the network address of that class A would be 192.0.0.0, and all you have to do is to convert it into a broadcast address is just change the zeros to 255. So 192.255.255.255 with the broadcast address. The same with class B network. So the network address would be 192.168.0.0 and the broadcast address would be 192.168.255.255. So all you're going to do is convert the zeros to 255. And for class C, the network address would be 192.168.16.0 and the broadcast ID would just be you convert the 0 to 255. So it would be 192.168.16.25. So this was a quick lesson on broadcast ID, which is also called broadcast address. So hope you guys got a good understanding of what it means, how we can easily get the broadcast address after a network address, and now I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on what is subnetting. So we're going to have an overview of what subnetting is, and in my further lessons we will study it in detail. So let's take a look at the concept first. So subnetting is the strategy used to partition a single physical network into more than one smaller logical subnetworks, which are also called subnets. So the subnets are designed by accepting bits from the IP address's host part and using these bits to assign several smaller subnetworks inside the original network. Subnets were initially designed for solving the shortage of IP addresses over the internet. So a brief summary, subnetting is that you take an IP address and divide it into further subnetworks or further subnets so that can be easier for you to get more IP addresses. So here are some benefits of subnetting. Subnetting reduces the network traffic by reducing the volume of broadcasts. It also helps to surpass the constraints in a local area network LAN, for example the maximum number of permitted hosts, as it allows us to get more hosts. And subnetting also enables users to access a work network from their homes, so there is no need to open the complete network. Here I have a picture of explaining subnetting. So as you can see, before subnetting, we have an IP address that is divided into its network identifier and its host identifier. So the blue part is network and host is yellow. But after subnetting, you can see that the network identifier remains same, but the host identifier is divided into two further parts. One of the part is remaining host identifier, and the middle part gets to be the subnet identifier. So in my next lessons, we're going to study in detail how we can subnet by using the hosts part, and we can subnet using the network parts. So this was the end of this lesson on subnetting, and I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on what is CIDR. So let's take a look at the concept first. So CIDR stands for Classless Inter-Domain Routing. So the CIDR was invented to keep the internet from running out of IP addresses. The classful address scheme, which is class A, B and C, of allocating IP addresses in 8-bit increments can be very wasteful. With classful addressing scheme, a minimum number of IP addresses allocated to an organization is 256 for class C. Class B allocates only 65,536 IP addresses, and Class A network, which is a little big, which allocates 16.7 million IP addresses. But these have also run out, so this type of IP address allocation is very wasteful. So what is the use of CIDR? With CIDR, a network of IP addresses is allocated in 1-bit increments as opposed to 8 bits in classful network. So the use of a CIDR notated address can easily represent classful addresses. Class A is represented by /8, class B is represented by /16, and class C is represented by /24. These are their bits numbers. The number next to the slash, that is for example 8/8, represents the number of bits assigned to their network address. So for class A, we have 8 bits for network, class B, we have 16 bits for network, and for class C, we have 24 bits for network. So let's take a look at an example of CIDR. So CIDR notation of a network address is 192.0.2.0/18. 18, what represents is that it says that the first 18 bits are the network part of the IP address. So the number after the slash always gives us the number of bits in the network part of the IP address. Furthermore, why use CIDR? With an introduction of CIDR addressing scheme, IP addresses are more efficiently allocated, and hence there is less risk of IP addresses running out anytime soon. The IP version 4 addresses with CIDR addressing scheme will eventually run out. To solve shortage of IP version 4 addresses, the IP version 6, which is a 128-bit address that we have studied, address scheme was introduced in 1993. So this was the end of our lesson on CIDR. Hope you guys got a good understanding of what it means and what are its benefits and how it can prevent the waste of IP addresses. And now I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on subnetting according to host. So we're going to go step by step, in depth, and do subnetting according to the host. So we're actually going to study with an example. I've made this example myself. So what we're going to do is take an IP address firstly. So we have this IP address of class C, which is 197.10.10.0. So this is our IP address, and we will take this and do our further subnetting. So now, As you can see, we have two routers, router 1 and router 2. So with this example, you can also see we have 4 other departments connected to it. One is the 10, 30, 20, 40. But as you can see, we have numbers 1, 2, 3, 4, 5 labeled. So these represent how many subnetting we will have to do. So we will have to do subnetting for number 1, which is for 10 computers, number 2, which is for 30 computers, number 3, which is for 20 computers, and number 4, which is for 40 computers, and number 5 is a subnet we will need between router 1 and router 2. So remember, there is always a subnet needed for the routers too. So let's start with step 1. So step 1 would be to just write your IP address and identify which is the network part and which is the host part of it. This is a class C IP address. So network part would be 197.10.10 and .0 would be the host part. So as we're studying subnetting using the host part, step 2 would be to write the network part as it is, but in the host part you convert it to binary. We've done the conversion of decimal to binary in our lessons, so you will not have any problem converting it to a binary version. So as you can see, I've just converted it and wrote 8 zeros, which is 8 bits and 1 byte. So step 3. In step 3, you need to remember this formula. The formula is 2 raised to the power of n minus 2 is greater than or equal to. So this is the formula you need to remember. And next what we do is, we put the number which is the maximum number of subnets we need. So 40 in our previous example, as you just saw, 40 is the maximum number. So in front of the formula, you're going to write that maximum value, which is our 40. And n would be 1, 2, 3, 4, 5, 6, 7, etc. So it goes on. So what we actually do is, we take this formula, write the maximum value in front of it, and we keep putting values of n of 1, 2, 3, 4 and so on until we get a number that is greater than and equal to 40 or our maximum value. So as you can see, if I've done it, 2 raised to the power of 4 minus 2 is not equals to 40 or greater than. 2 raised to the power of 5 minus 2 is also not. 2 raised to the power of 6 minus 2 is greater than and equal to 40, as 64 minus 2 is equal to 62. So 62 is equal to or greater than 40. So we will take our number of n from this. N is equals to 6. So in step 4, what you're actually going to do is, again write your IP address with the host part converted into the binary version. And you're going to this time start from the right side. As you can see, the arrow I've labeled, it's from the right side. You're going to count 6 bits or the number of n you got. So we got n is equal to 6. So you're going to count 1, 2, 3, 4, 5, 6. And until you get 6 bits, just mark it. The rest of the bits that you will be left with, you will give them to the network. So as you can see, if I've labeled them, so we have counted 6 bits. These are for the host, and the rest remaining 2 are, you will give it to the network. So how will you give it to the network? All you're going to do is just convert those numbers into 1. So you're just going to write 1, 1 in place of those 2 zeros. As we know, network represents 1 and host represents 0. So 197.10.10.11, and then we will write 6 zeros. And then what you further do is, remember the values we did in the conversion of decimal to binary, you will write those under your 8 bits of the host part. So you've seen I've written them. So we have 1, 2, 4, 8, 16, 32, 64, 128. You also need to remember this, and I've also showed you guys a quick technique how you can do that and remember it in one of my lessons. So you're going to write those number value rows under that binary converted version, and you're only going to add the 2 values that come under your network 1 parts. So as you can see, we have 128 and 64 coming under our 2 ones. So you will add them, and after adding them, you will just write that value. So 197.10.10.192 as 128 plus 64 is equals to 192. That will be our further decimal value. So once you're done with step 4, we're going to move on to our step 5, which is that you will make the subnet mask of the subnet we just made. So as you can see, by default subnet mask of our class C is 255.255.255.0. We've already learned this. But the subnet mask after would be 255.255.255.192. So you write the network parts as 255, and in place of the host 0, we just write the 192, the number we just calculated above. This number, this decimal value, we write it in our subnet mask. So step 6 is the main part in which start making the subnets. So as you can see, the subnet one I've written is 197.10.10.0/26. So why did I write /26 after it? As you know that in our CIDR lesson, we learned that class C has a CIDR of /24, which is standard for class C. But why did I write /26 over here then? What I actually did was, I took the 24, which is the basic one for class C, and I added +2 to it. Why did I add 2 to it? So we're going to go back to our step 4. And as you can see that we gave 2 of our bits to the network part. And as you remember, the CIDR is always the total of our network bits. So we added 2 more network bits. So those 2 network bits were added in our 24, which gave us 26. So also remember this, that whenever you see an IP address with / any other number than 8, 16 and 24, you're going to know it is a subnet of an IP address. So the first subnet will always be 197.10.10.0/26. The network bits will be added to the IP address class normal CIDR. And so next you can see that subnet 2 is 197.10.10.64. So again, you're now going to ask me that how did this 64 came? So this is a little tricky, but you will need to learn this by practice, and you will get it easily once you do more questions and more examples. So we're going to go back to our step 4, and you can see that there is a 64 written somewhere on this step. So as you can see, 64 is under the first 1 bit from the right side. It is under that. So the rule that you need to remember is that you're going to always start from the right side, and the first bit you changed, the first bit from the right side. As you can see, the first bit we changed from the right side is this one, which has a 64 under it. So this one, you will take the value under it, which is 64, as you can see. So we're going to go back to our step 6, and after that, in our second subnet, we will add 64, meaning that number to our 0. So as you can see, I wrote the same thing, except I just added 64 to the last 0 octet. So let's continue the step 6 by making more subnets, and let's see how many subnets we can make. So the rule for that is you just keep on adding 64, or that number we decide by the rule, and we keep on adding it until we reach a maximum number. And what is that maximum number? Let's look at that too. So our third subnet would be 197.10.10.128, as 64 plus 64 is 128. Our subnet 4 would be 197.10.10.192/26. So 192, why? Because we added 64 to 128. So this was our fourth subnet. And now we're going to add 64 to 192. But what do we get? We get 197.10.10.256. But remember, our maximum value in a decimal number of an octet can be 255. So 256 is greater than 255. So there will be no subnet 5 of this one. So this was the end of my lesson on subnetting with the host part. Hope you guys got a good understanding, and again, if you have any questions, do tell me in the comments and I will try to answer them all. And also do check these steps again and again so you guys know clearly how and what we do to make subnets. And now I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on subnetting according to network. So in the previous lesson we did subnetting according to the host, and in this lesson we're going to do how we can make subnets according to the network. So we're also going to study with an example this time. The IP address we're going to take this time is of a class B IP address. The IP address would be 157.110.88.0. So the steps are almost the same as subnetting according to the host one. So if you clearly know and understand how you can make subnets according to the host, you will easily able to do the subnetting according to the network, because the steps are almost the same. There is only one single difference that we will see. So step 1, you're just going to write the IP address and identify which part is the network part and which part is the host part. For step 2, you're going to write the network part same. So 157.110 you will write same, but for the host part you'll just write the binary version, which is 16 bits of 0. For step 3, if you remember the formula, we use the formula 2 raised to the power n minus 2 is greater than or equal to, and you use the maximum value you need in front of it. So 30 is our maximum value, for example. So you're going to use n as 1, 2, 3, 4, 5, 6, 7, 8, so on, and unless you get a number that is greater than or equal to 30. So 2 raised to the power 4 minus 2 is not equal to or greater than 30, but 2 raised to the power 5 minus 2 is equal to or greater than 30. So 34 minus 2 is, which is equal to 32, is greater than 30. So n value would be 5. So now comes the main difference between subnetting according to host and between subnetting according to network. So in step 4, you're going to write the same thing as it is, but this time you're going to go from left to right. So you're going to count the zeros from left to right and mark the 5 bits, because our n value is 5. You're going to mark the 5 bits. So as you can see, I've marked them 5 bits of host, and these we will give to the network. In the subnetting according to host one, just remember that you go from right to left. In subnetting according to network, you go from left to right. So again, you're just going to write the same IP address, but instead of the zeros you marked, you're going to write ones. Next, you will just write your default subnet mask, which is 255.255.0.0, which is a class B standard subnet mask. And then you're going to write the subnet mask after. So that would be 255.255, the network part remains same. And next you will just write 248.0. And how did we get 248? Why did we write 248 over here? So as you remember, in the subnetting according to the host one, we wrote the values over there on top of them, as you can see, 1, 2, 4, 8, 16, 32, 64, 120. And you're going to add the values that come above the ones. So you can see when we add 8, 16, 32, 64, 128, we get 248. And next is our step 5. So in step 5, our first subnet would be 157.110.0.0/21. So why did we write 21 over here? Even though a class B IP address has a CIDR of /16. We added 21 this time because we added all the network bits. And when you count the network bits, you'll see 16 plus 5, which is 21. So next you're just going to make further subnets. But what will you add this time? So again, you're going to go up to your step 4 and you're going to go from right to left. This is the same rule as subnetting according to host. And the first number you changed, the first bit you changed, the number value above it, you will choose that. So we can see we have 8. So we will go back to step 5 and see that we will keep on adding 8 to our last octet. So you can see subnet 2 has 8, then subnet 3 has 16, then subnet 4 has 32. We keep on adding 8. Subnet 5 has 40, subnet 6 has 48, and then we keep on adding 8s to the last octet until we reach a number which is the maximum number. So our last subnet would be 157.110.0.248. And total, when you write all of them and you count them, you will see you will get 32 subnets. Here is a small question. So the question is, how many number of hosts per subnet? So to find that, all you're going to do is write your formula, which is 2 raised to the power n minus 2. Just you're going to write that. And in the n value, you're going to put the number of host bits. So our host bits, as you can see, let's go up and you can see that our host bits left are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you're going to write that as n and you will get your answer to how many hosts per subnet you can get. So this was the end of our lesson on subnetting according to network. Hope you guys got a good understanding and know how you can make subnets from an IP address. And now I'll see you guys in my next class. Hey guys, and welcome to this lesson on VLSM. So what is VLSM? VLSM stands for Variable Length Subnet Mask. In VLSM, the subnet design uses more than one mask in the same network. It is used to increase the usability of subnets as they can be of variable size. It is also defined as process of subnetting of a subnet. So we learned that subnetting is when we divide an IP address. But when we further subnet a subnet, meaning when we further divide a subnet, it is VLSM, Variable Length Subnet Mask. So what are the benefits of VLSM? VLSM provides the flexibility that reduces the number of wasted IP addresses in each subnet. By wasting fewer addresses, more space remains to allocate more subnets. VLSM can also be helpful for both public and private IP addresses, but the benefits are more dramatic with the public networks. So let's take a look at the implementation of VLSM with an example. So suppose there is an administrator that has 4 departments to manage. These are sales and purchase department with 120 computers, development department with 50 computers, accounts department with 26 computers, and management department with 5 computers. So if the administrator has IP address 192.168.1.0/24, remember in CIDR we learned that CIDR is the number after the slash, which is 24. So we can see that it is clearly a class C IP address. So the department-wise IPs can be allocated by following these steps in the next slide. So for each segment, select the block size that is greater than or equal to the actual requirement, which is sum of host addresses, broadcast addresses, and network addresses. So you make a list of possible subnets. So as you can see, we have the slash notations and host subnets. So the notations are slash 24, 25, 26, 27, 28, 29, 30. So these are the different notations CIDR slashes. And we have the host subnets, which are 254, 126, 62, 30, 14, 6, and 2. So next what you're going to do is arrange all the segments in descending order based on the block size that is from highest to lowest requirement. So sales and purchase is the biggest one, which is 120, then development, which is 50, then accounts, which is 26, and then management, which is 5. So the highest IP available must be allocated to the highest requirement. So the sales and purchase department, which is the highest one, gets 192.168.1.0/25, which is 126 valid addresses that can easily be available for 120 hosts. So the subnet mask used is 255.255.255.128. So it's really easy, as you can understand, that you allocate the IP address which has the most valid addresses to the highest number of requirements. So the next segment requires an IP to handle 50 hosts. The IP subnet with the network number 192.168.1.128/26 is the next highest, which can be assigned to 62 hosts, thus fulfilling the requirement for development department. The subnet mask used is 255.255.255.192. Similarly, the next IP subnet 192.168.1.192/27 can fulfill the requirements of accounts departments, as it has 30 valid host IP, which can be assigned to 26 computers easily. The mask used is 255.255.255.224. And the last segment requires 5 valid host IP, which can be fulfilled by the subnet 192.168.1.224/29, which has the mask as 255.255.255.248 is chosen as per the requirement. So the IP with the mask 255.255.255.240 could be chosen, but it has 14 valid host IPs and the requirement is less in comparison, so the one that is comparable with the requirement is chosen. So this was the end of our lesson on VLSM. Hope you guys got a good understanding of what it means, how we implement VLSM, and how we can use VLSM to subnet further subnets. So this was the end of our lesson, and I'll see you guys in my next one. Hey guys, and welcome to this lesson on servers. So we're going to look at what is a server and how it is used and what's its function and types. So what is a server? A server is a computer or system that provides resources, data, services, or programs to other computers, known as clients over a network. It accepts and responds to requests made by the client. Servers are commonly used to deliver services that are constantly required. Most servers are never turned off. So servers are like the main unit. From there, all the information is sent and received, and it accepts and responds to any requests made by the client. So in a network, all the computers, which are known as clients, are connected to the server. So how a server works? To function as a server, a device must be configured to listen to requests from clients on a network connection. When a client requires data or functionality from a server, it sends a request over the network. The server receives this request and responds with the appropriate information. So a server will often perform numerous additional tasks as part of a single request and response, including verifying the identity of the requester, ensuring that the client has permission to access the data or resources requested, and properly formatting or returning the required response in an expected way. So here are some common types of servers. They are file servers, print servers, application servers, web servers, DNS servers, mail servers, database servers, virtual servers, and many more. But these are the few common types. So this was the end of our lesson on servers. Hope you guys got a good basic understanding of servers, how they are used as the main unit from which all the activity takes place in a network. And now I'll see you guys in my next lesson. Hey guys, and welcome to this lesson on DHCP. So what is DHCP? DHCP stands for Dynamic Host Configuration Protocol. It is a network protocol used on IP networks where a DHCP server automatically assigns an IP address and other information to each host on the network so they can communicate efficiently with other endpoints. DHCP also assigns the subnet mask, default gateway address, domain name server, which is DNS address, and other pertinent configuration parameters. So DHCP is actually a configuration protocol that automatically assigns the IP addresses and different kinds of information needed. So you don't have to separately assign and select all these things. DHCP does it all for you automatically. So what is the use of DHCP? DHCP is needed to simplify the management of IP addresses on networks. No two hosts can have the same IP address, and configuring them manually will likely lead to errors. Even on small networks, manually assigning IP addresses can be confusing. Automating this process makes life easier for users and the network administrator. So if you try to assign IP addresses manually or make subnets manually, it's really time taking, and it can also lead to errors because there's so much decimal work. So DHCP does it all for you automatically. Here are some benefits of DHCP. So one of them is that there's accurate IP configuration. Your IP could always be accurate without any errors. There would be reduced IP address conflicts. There will be automation of IP address administration. DHCP would also administrate your IP addresses automatically. And lastly, there is efficient change management, as there is no time taken. DHCP quickly just automatically assigns you all the information you need. So this was the end of our lesson on DHCP. Hope you guys got a good understanding of what DHCP means, how it is used, and why it is used. It is used to automatically assign IP addresses and any kind of information, so people don't have to do it manually, and it will take less time, so it is more efficient. And this was the end of our lesson.